Hello dear students, welcome back to Learn Physics. In today's topic, we are going to discuss about the portion laws of motion. So in this chapter, last class we learned about constraint equation. So in that constraint equation itself, we did some numericals, and today's video also we are going to do some numericals about that constraint equation. Here I am considering a fixed plane here, and in that fixed plane, and here it is fixed over here, and here this end also it's fixed. Okay, here I am going to consider a pulley which is kept over here. This side a pulley is there, and one end of the pulley is attached with a mass capital M, and another end is attached with another pulley which is fixed at this end, and other end of the pulley is attached with the mass. The same mass is kept over here. So here we need to find out acceleration and tension we need to find out. So if we need to find out acceleration and tension, what should we do? First we need to find the equations for each masses in terms of acceleration and time. So first I am considering the first mass m. Here tension is acting in this direction and acceleration also will be acting in the same direction. Next we are going to consider for the next mass. Second mass which is kept over here. In this case mg will be, that is mg will be acting downward direction, and here tension will be acting in the upward direction. Right? So these are the forces which is acting on this object. Now we can give the two equation for that. Here T equals m into A. Right? So here in this side T minus mg. So T minus mg equals minus ma. Or you can, so A is acting in the same direction. So here A is acting in the opposite direction. Acceleration will be acting like this only, right? So what is the direction of mg? Same direction only. This acceleration also acting, okay? Otherwise you can, as I said in the previous videos, you can take ma also positive. Or you can write like this also. Mg minus, m is capital, mg minus t equals ma. Okay, so here instead of ma, I can give t. Therefore, t equals, this t also I am taking to the right side, t plus t, 2t. Okay, so here we will be getting it as mg equals 2t and t equals mg divided by 2. Okay, so this is the value which we are getting for T. Tension T equals mg by 2. If T equals ma and T equals mg by 2, what will be A? Can be written as g by 2. Clear, children? So in such kind of questions, here we need to first find out write down the equations. What are the draw free body diagram, and in the free body, using free body diagram, you can write down the equation relating T, mg and A. Okay, and then here you can find out by solving those two equations, we can find out the tension and acceleration. Okay, clear, children, this question? So the same way we will be doing another question. So next second question we will be writing it as, let me take the second question here. Yes, first I'll draw the diagram. This is the fixed end through the wall, and this is the ground surface, and here it is attached with a pulley, and this pulley, one end of the pulley is kept over here, and one end of the pulley is attached with a mass m1. Here mass m1, and this is attached with a mass m2, and here this is m2. Here we are applying a force F. Assume that there is a negligible friction between the block and the table. Between the blocks and the table, there is not that much frictional force. So no need to consider about the friction. Compute the tension in the cord connecting M2 and the pulley and the acceleration of M2 if M1 equals 300 gram, M2 equals 200 gram, and the force applied is 0.40 Newton. So here we need to find out the tension in the cord connecting M2 and pulley. M2 and pulley. What is the tension acting over here? This one we need to find out, an acceleration of M2. Okay, so here what and all we need to find out? Tension which is acting on the pulley and acceleration of M2 we need to find out. So here in this question, see here what to say. First we need to draw the free body diagram. First I'll draw for M1. M1, which in first we need to M1 which and all forces will be acting, that one we need to find out, right? So anyway M1G is not there. Acceleration and tension we need to find out. So tension T will be acting in this side. And for here acceleration also will be acting along the same direction. Now I am going to consider for M2. When I am considering M2, acceleration is acting in this direction, and but here another tensional force also will be acting in this direction, right? To this one, to the fixed end. So that is altogether 2T force will be acting in this direction. So here a tensional acceleration is acting in this direction and tension also acting in the same direction. And here also a tensional force is acting in the same direction. So here together, here it not this direction, here it a tensional force will be acting in this direction towards the pulley. Right, tension will be acting towards the pulley. So it is acting towards the pulley. So here T and here T. Together it is getting 2T. So in such kind of cases, if the tension is doubling, then the acceleration will become half of the tension. So here it is 2T is the tension which is acting. So acceleration will be A. So see, if here T is the tension acting on over here, here the acceleration will become 2A. If tension is doubling, acceleration will become half of the previous one. So here instead of A, we need to write down 2A. Clear? So in such kind of cases, if the tension is getting doubled, the acceleration will become half. So initially acceleration is 2A and then only here acceleration will become A. Here we draw the direction of acceleration. I'll tell you once more the whole thing. See here children, listen carefully about the M1. First I am going to consider for M1. M1 is for M1 which and all forces will be acting. Tension will be acting in this direction towards the pulley and acceleration also acting in the same direction. Here the tensional force is acting in this direction. And next I am going to consider for M2. So when I am considering M2, 2T is the force tension which is acting towards the pulley and acceleration will be acting in the opposite direction. Now I got it as tension is twice that of the initial tension. If it is tension is doubling, then acceleration will become half of the previous one. Either we need to take A by 2 over here or we can consider here as 2A. In which way we want to, you can consider. Okay. So here we will be taking, the rest of the things we will write over here. Next is, see, we will write down the equation. So here T equals 2A. From first one I am getting it as T equals 2A into M1 and here 2T minus F is the force which is acting over here, right? So F minus 2T which is equal to M2 into A. Okay, so here from here I am getting it as T equals 2A into M1. Already we got it as 300 grams, that is 0.3. So 0.6A I am getting. So F minus 2T. 2T is, I can write it as 2 into 0.6A equals M2 0.2 into A. Right, so I can write it as F force. How much it is given? Force is given as the value is given over here. It's F1 it is given as F is given as 0.4 Newton. F is equal to zero point 0.4 minus 1.8 A equals 0.2 A, and zero point 0.4 equals, when I am taking to the other side, it is 2A. Therefore, A I am getting it as 0.2 meter per second square. So, tension I can write it as 1.2 A. 1.2 Newton. This will be the tension which I am getting over here, and here the acceleration I got it as zero point 0.2 Newton, 0.2 meter per second square. Okay, clear children? T equals 2A into M1 and F minus 2T equals M2 into A. F minus 2 into 0.6A equals, what is that? 0.2A. 200 gram, 0.2A. So, F we got it as 0.4. So, 0.4 minus 1.8 equals this one. Coming to this side, 2A. Acceleration I got it as 0.2 meter per second square. Here they asked us to find out the acceleration which is acting on M2. So, M2 we are getting an acceleration of 0.2, and what is the tension which is acting between the pulley and M2. Tension which is acting between pulley and M2 is 2T. So, here 2T will be equal to 1.2 into 2, 2.4. 2.4 Newton will be the tension which is acting over here. Clear? Okay, now we will move to the next question, that is here. Find the acceleration of the block, which is find the acceleration of the block of mass capital M in the situation given here. So we need to find out the acceleration at the point. All surfaces are frictionless, it is given. This angle is 30 degree. So while seeing the angle itself, you will understand how to do, right? So here it is making an angle 30 degree. So here I can divide this into two components. Okay, here these are the two components which is acting over here, and tension will be acting here. This is the acceleration will be acting in this direction, and this is T. Tensional force is acting in this direction. Here another T is acting over here. Here T is acting, and mg will be acting downwards. Now I am going to consider for 2m first. Okay, for 2m, 2mg will be acting downwards. Okay, towards the pulley it is acting. So tension is acting over here, and one tension is acting over here. Then what will be the tension which is acting in this direction? So here T is acting upward, T is acting upward. So together it will be 2T will be acting upward direction. 2T is the tensional force which is acting in the upward direction. Since it is 2T and acceleration, if I am this will be moving upward direction. Since it is moving upward direction, we can consider this as 2A, and this as A we can consider. Okay, because if I add, and what is the tension is twice, acceleration will be half of the previous one. So here I am considering acceleration as A, which is acting downward direction. This is for 2m. Now I am going to consider for m. M it is like this. So here what will be the acceleration which will be acting over here? Here this is 30 degree which is acting, it is acting along, it is not a straight line, right? It is acting through an inclined plane it is acting. So what are the forces acting on this inclined mass? Tension is acting over here through the inclined plane. What is the force which is acting over here? Here mg cos 30, this is mg cos 30, and here it is mg sin 30. So here it is mg sin 30 which is acting here. So T and mg are T is in the same direction of A, therefore I am taking T as positive. T minus mg sin 30 equals mass into acceleration. Mass into acceleration, while I am considering mass is capital M, acceleration become twice of the previous one. So here it is 2A. Because here 2T is the tension which is acting. Here only T is there. Therefore acceleration will become double the previous value. Now our equations are, so we can write down the equation as here T minus mg sine 30 is 1 by 2 equals m into 2a. Another equation which we got over here is, what is the other equation? From this one, we can write it as the second equation. I'll write down. Other equation, we can write it as A is acting downward direction. So 2mg, I am considering it as positive. 2mg minus 2t equals 2m into A. Okay, while we are solving this one, we are getting the final equation. So 2ma plus mg by 2 equals t. This is one equation I am getting over here. This one I can write it as 2mg minus 2ma equals 2t. These are the two equations. So while we are solving this equation, acceleration we will be getting it as g by 3. Okay, so try to solve this one. You will be getting the final answer clearly. Clear, children, how we will be solving such kind of equations? So I hope this is clear for you. And if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.